Hello there, this is NopeName. Welcome to the second episode on the series about creating a 32-bit computer inside Minecraft with a datapack and blocks. And last time we only did this basic setup here. This will be the heap, this will be the stack. This is the program memory with the current instruction loaded in this register. Probably. And these are 16 registers with 32 bits each and 2 helper registers down here, which are needed because this is Minecraft. And if you haven't seen the first episode, I recommend you to watch it, at least the first few minutes, because the rest is kind of boring since I'm only doing that stuff here. But in this video we are going to start with the datapack, and therefore we first have to get the preset datapack. And where do I have it? Minecraft. There we go. How do I get that to that place? Let's see. So you can't actually see what I'm doing. I'm just moving some files around. Datapack. Okay, let's see. Yeah, we have that thing in here. That's a preset pack which I wrote a while ago. It simply contains the most important stuff you need, or gives you an example of what you can do. Don't need that. Setup function, but we don't need the message. Tick. Do we need a tick function? I don't know. I will just keep it for now, but we have to rename it. How are we going to name it? I think first we have to think about the structure of the overall data pack. Well, I can rename the overall data pack. Minecraft 32-bit. And that closed everything. Okay, so the thing is, if I call this folder here preset, inside the game, if you want to run the function tick, for example, you're going to run function. Why isn't that working? Oh, right. Yeah, in chat you are writing /function and then preset tick to run this function here. But I also want to do something like CPU and RAM and stuff like that. So therefore I'm going to make more of these folders here. So let's rename it to this is the main. I just call it main. Here we will do something like player spawn and things like that, and the actual computer will be it's duplicated, will be here we have the CPU and RAM down there. But those don't actually need setup and tick, I guess. Or maybe... No, I think it's actually better, because main should call the other tick functions and the other setup functions. Yeah, that's, I think, a good structure. But in Minecraft, we just say that main is the entry point of the program, so to say. So this will make Minecraft run the main tick function every game tick. And when the data pack is reloaded, it will run this function, main setup, this one here. And in here we can call the other functions like CPU setup, RAM setup, and I haven't done more. So yeah, if you're wondering what kind of extensions, packages I have here, check out the video description in where you can find all the tools I'm using here. And if you have any questions, just ask me in the comments. Okay, so maybe I should only display the data pack here. No, I'll do it like this. Okay, so we have already a basic structure with main, CPU and RAM, and oh yeah, down here we have that kind of stuff. Okay, I still haven't decided how big I want to make the program memory, but I think I'm just going to ignore that for now. And I want to start with the most interesting part of the computer, the CPU. And the CPU only works with registers here. In real life you also have different cache levels. So that's basically, you have a RAM, a few gigabytes usually on real computers, and while the RAM is quite fast, it's not fast enough, so the computer will load those parts of the memory which you actually need at the moment into a smaller but faster memory next to the CPU or inside the CPU often. But we won't do that here. We want to keep it simple, so the CPU is only going to work on the registers, and then we have a RAM, and it's already hard-coded, divided into heap and stack, so we don't have to deal with the heap is going inside the stack and stuff like that. Okay, so only the registers for now. And I said that's the most interesting part, at least for me, but we still have to do a lot of boring work. For example, right now we have to write functions that will copy those registers up here into the helper registers down there. We need that because we can't, for example, if I want to add the value from this register to this one and store it in this one, that's hard to make. I can do something like we have an armor stand here, and it's going to perform operations relative to its position, but it can't do it also relative to itself with those other registers. It's complicated, so I will do something like, if you want to perform something here and here, this one will be copied to that location. So we have fixed coordinates, and then there will be an armor stand here, and it will perform actions relative to its position here and on absolute coordinates down here. So we can combine everything in one command, and the result will be written here to these absolute coordinates, and at the end it will be cloned to the result register, to the actual result. So how are we going to structure the data pack inside these subfolders? I think I want to divide it into public and private, and the private functions are only called from within the CPU functions. So for example, tick can call the setup function but this tick function can't call that setup function, so it's private, something like that. And I will do it my usual way. A new folder directory called zz-private, zz, because that way it will, if you do something like function reload function, if there is this zz-private at the beginning, it will show up at the bottom. Or actually, we still have that stuff in between. Maybe I should actually do it like this. So let's copy this thing again. That's it. Private. And in here, going to make folders for each subcomponent of our data pack. I think main doesn't have private stuff. Okay. So setup and tick are called by main, so we will keep those public. But if I want to call a function in here that is only used within the CPU subcomponent, I'm going to do function zz private CPU and then the function which I want to call. And that way, if I run function, up here I only have the functions which are called from one component to another, or even by the player using /function, and at the bottom we have all the zz private stuff. Okay, that should keep things somewhat clean. So yeah, let's start. All the functions which copy registers back and forth are only used inside the CPU, so the RAM doesn't know about this stuff. It will simply, grab this register and store it back there, and the other way around, and it simply ignores the existence of these things. So we will write them into the register, into the private part. Okay. So yeah, we have another subcomponent which only deals with the registers, and here we do something like, how am I going to call that function? It's going to move one actual register to the helper input register. To helper mc function. Okay. I think there's an atom setting that allows me to print this stuff into files by default, but I don't know how to do it. Okay, so we want to use an entity. It's not the fastest way, but yeah, I want one armor stand, or no, an area effect cloud is better. Is it? Because I want to, no, I don't want to. Okay. Yeah, I will use an area effect cloud that is teleported to a register which we are currently working on. Does that make sense for this operation? I do want to make some optimization, but okay, now I'm going to use a scoreboard. Alright, so wrong way. We need a scoreboard, and we will write that into the setup function for the CPU, since this scoreboard will be used by the CPU. Scoreboard, objectives, add reg ID, register ID, and it's simply a dummy. Okay, so execute if score. Oh wait, let's just call it reg for register. Maybe we need some other stuff. And we have a fake player called ID. And if I want to perform an action on register number 0, which is the first one, I'm simply going to do scoreboard. I'm still not used to schedule being there. Scoreboard players set ID reg for register and then 0, and after that I can perform some action and it will perform that action on register 0 or 1, 2 and so on. Again, wrong direction. Okay. If score matches 0, run clone okay. Oh, we actually need one more. Okay, we have 16 registers in total. So the ID goes from 0 to 15. And the x coordinate changes by 2 for every step. Let's see if the extension is smart enough. So this should be no, okay. I already know that this extension is not smart enough for negative values. Oops. Let's see if the numbers are correct. Yeah, I have to change them back there as well. It's the opposite direction. I'm dumb. So yeah, this is how I'm editing my files here. Oh god. Okay, let's try again and act as if these were positive numbers. Come on, you can do it. It can't. Oh, come on. 1, 3, 5, 7, 9. but it only... Something's wrong, I can feel it. 9, 2, minus 32. 32, yes. 2, 5, 6, 8, 10, 12, 14. Clone. Beep, 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 beep. Ah, yes, can't overlap. Ah, come on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What the fuck? There we go. Okay. So now that we have that going, we still have to copy them to this location. Yes. Okay, let's make a test run. Reload, let's see, no errors. Okay, 0, 1, 2, that's not actually binary. Scoreboard, player, set, ID. Ah, we missed something. In main, we have to call function CPU setup. Reload, and now we should have set ID register. Yes. Let's say to set it to 0, and to see it correctly I have to remove all that stuff. Okay, function set private CPU registers to helper number 1. Okay, that's good. Number 2, number 3, number 15. Yes, looks like it works. And if we do some crazy stuff, it will just ignore the input. Okay. And now we pretty much just do the opposite. And how long am I recording already? Oh boy, I'm really slow. Yeah, a lot of you probably already turned off your device, or maybe you use these videos to fall asleep, I don't know. From helper will clone this register to one of these, depending on the ID. And it is at -11 instead of 9. I'm not good at handling numbers, as you might have guessed. Okay. Put them in the front. And we only need the start address, the start location of the others, and that is 31, right? Yes, it is. From 0 to 31. Okay, that was a bit easier. Hopefully I haven't messed up. Reload. Let's see, output looks good. Let's set the ID to something useful. And we should have another function. Yes, from helper. Okay. That's good. So we can clone any register here to this helper register and copy this one to any of these. And that's it for this episode. This series will be really long. Oh boy. Okay. Yeah, thanks for watching. See you next time.